Welcome to Scalable CTO with Bob Dickinson. Today I'm going to talk about TeamSpark Workbench, which is a side quest. I'm titling it Solving Hard Problems with Large Language Models. So let's jump into it. Just a quick checkpoint with the main quest, which is the TeamSpark social app. TeamSpark.social used to be called TeamSpark.ai. It's a social network aimed at teams and groups. Privacy first, community focused. We've got a web client and native mobile clients, and it's coming really soon. It's imminent to launch into beta. It's pretty exciting. In building TeamSpark Social, we use AI tools, dev tools pretty heavily, GitHub Copilot at first, and then later migrating onto Cursor for the web apps. And I feel like we've been at sort of the cutting edge of some of those things in terms of how we use those tools and adopting some of the latest techniques to try to make them more efficient. And we've also deployed AI features in the app. So we have summarization and question answering about the groups and posts and basically the content of the app. We use Google Vertex AI and Gemini models with the RAG implementation, with vector indexing and search, so that we can search our social media graph to do some of these AI functions. And we also built a prompt studio, which I talked about in one of the previous AI podcasts, which is our internal tool for developing and testing prompts. It allows us to tune models and test prompts against each other and test them against live data. So we built some tooling around AI in addition to using AI to build the product itself. But what I want to talk about today is something we're calling TeamSpark Workbench, which is a new approach to solving hard problems using large language models. And it's inspired really by a lot of the software development tools that we use, Copilot and Cursor and a bunch of others. Seeing some of the awesome functionality those tools have, but also understanding the limitations and sort of why they have those limitations. I think there's a lot of potential to solve some hard problems in ways that maybe we aren't doing right now. And that's also inspired a lot by how tool usage has evolved, especially very recently. We were doing tool usage 6 or 9 months ago with Gemini, which was one of the first to support it. Now pretty much every model supports it. And with this model context protocol, MCP servers popping up, there's hundreds of thousands of tools. You can connect language models to virtually any kind of tool that you want. Tools that run in the cloud or on your local machine to do all kinds of interesting things. And I think the combination of all those really made it seem like there was an opportunity to solve some harder problems outside of software development, maybe also inside of software development, but I'm not as excited about AI to solve, to put myself out of a job as I am about maybe solving some other problems with it. And so specifically thinking about custom prompts, rules engines, tool usage, and having a high level of choice and control over models, which model you're using, how you tune it, and the context that you give to those models. I think there's an opportunity to build trainable, tunable agents that can learn and have memory and sort of solve harder problems in ways that maybe some of these tools right now aren't doing. So I'm going to review a little bit how LLMs work and how context works, because that's going to be a big part of what this tool does. And then I'll do a demo. And if you just want to see the demo, you can just drag the little slider across until you see the demo start. But for the rest of you, so let's talk about LLM basics a little bit. So these models are trained on large data sets. And once they're trained, the model is fixed. It's just a big state machine. You put text into it, you get text out of it. The models don't learn or change in any way as you use them. They don't remember information. They don't acquire new knowledge or skills. They are what they are when they're trained. And the illusion of learning or memory, and to some extent reasoning, is created through context provided by the client to the model. So by the chat app or by the dev tool or whatever. So to the extent that you're using something like ChatGPT, and it seems to remember things or it seems to learn behaviors, it's because it has context that the chat client is maintaining on its behalf, not that the model is actually doing those things itself. And I'll give you a kind of an example of that. When you write your first app to call a model, you might do something like this. If you literally just kind of go to the Hello World tutorial, it'll say, oh, here's how you connect to the model, and here's how you send it a message, and here's how you get a response. And when you do that, you say, hello, my name is Bob. And then the model says, hey, Bob, how can I help you? And you say, what's my name? And he says, I don't know. I have no access to that information, because he has no state. He has no memory at all. So you're saying, well, how does ChatGPT work? How do these other things work? Well, the way that actual chat apps work is that you send that first message, it responds. And then when you send the second message, what is my name? Along with that, you send the previous messages that you've sent. So that we're going to call that context. But everything that you said and it's replied to before gets packaged up. So you can sort of imagine how this is going to grow over time. You're going to send it something, it's going to send you an answer. You're going to send it everything in the conversation before that, and then it's going to send you an answer, and you're going to keep tacking the questions and answers onto this context and sending the whole thing over every single time. So that's sort of how it works. It's a little some optimizations, but that's the general gist of it, is you have to pass that context every time. And that context is, for a basic chat app, it's things like system prompts, which are the engineered prompts that the chat app authors put in place to try to guide the models to give you the right kinds of answers. It's all the previous chat messages, as I just said. Sometimes those might get summarized. Sometimes it might truncate things. It might try to sort of be clever about understanding how to minimize the amount, but keep all the entropy, or as much entropy as it can. And increasingly, we're seeing like remembered information. Some of the AI agents now are doing things, or the chat bots are doing things where they will essentially be able to tell something is important and stick it into a database, and to be able to use use RAG or some kind of a tool to go get it out later. So sort of some privacy and security concerns around that. But anyway, they're getting a little smarter about trying to remember relevant information. But again, that's not happening in the model. That's happening in the app that's running the model. And when you get into more sophisticated AI tools and agents and some of these, more fancy, build a whole app from a prompt kind of tools, they're adding a lot more kinds of context. So they're doing RAG, so they're bringing in documents and data, doing semantic database searches and web searches. They're using rules and rules engines, and sometimes being smart about how to include those by context. They're using tools increasingly. I'll show you some examples of that. And then just any other kind of app data, like in a software app, instead of just shipping over all the source code, if you're more sophisticated, maybe you build a abstract syntax tree or something to represent the relationship of all the pieces of the code, and you send that over, something that the OLM can understand. So tools and agents, as they're getting more sophisticated, are sending more context. And in a lot of ways, that's why we're seeing this increase in, apparent reasoning skills and functionality and just general ability of these models. Is not so much because the models are getting better, they're getting a little better. It's because the tooling is getting a lot smarter about shoving a lot more context and giving the model a lot more to work with. So I'm going to use another word, inference, which you probably heard. So inference is basically the process of converting your input or your context into output. So that's how we get our result. And the compute cost or performance of the inference operation is a function of the input size and the output size measured in tokens combined with the efficiency of the model itself. So literally the actual compute cost of doing these operations is directly related to the size of the input and the size of the output, which means if you send more context, it costs more. Different models support different context windows. We're starting to see models with very large context windows, which is kind of exciting to be able to send 1 million or 2 million tokens. So you could send, a giant amount of data to these things, but you have to send it every time. So it's depending on the application, that can be prohibitive. And as I said, most apps, the recent accumulated context or a summary is sent over every single inference call. So you can sort of imagine if you're going back and forth and having lots of conversations, the cost can sort of add up. And I'll give you just a quick example. So let's say you have a small code base, 2,500 lines of code. So it's about 20,000 tokens for the whole code base. And let's say you had an app that sent the whole code base over every time you ask it a question. And you ask it 5 simple questions. And in each of those questions, the AI responds with one tool call. So it'll need to look at some file on the local system, or maybe try some build operation, or look at error output or something like that. So let's assume you ask it 5 questions. It asks you to run 5 tools in those 5 questions, and about 1,000 output tokens per turn on average. So this is like a small code base, and this is a 5-minute session of writing a feature. This is not like all day. This is something that's going to happen literally in 5 or 10 minutes. And in that, you're going to run 200,000 input tokens through and 10,000 output tokens, because you're going to run the 20,000 tokens of the whole code base every time you ask it a question and every time you give it a tool response. Which means on GPT-4, with the model that's big enough to hold that context, that's $13 to run that inference. On Claude, it's actually like $3 now, but when I made this slide 3 days ago, it was $6.60, and Gemini 1.5 Pro was 29 cents. So the costs vary widely, but even 29 cents, if you're doing this all day, every day, all the time, those things are going to start to add up. There's a cost calculator that I like that's right here. So I plugged our example in. So 20,000 input tokens, 1,000 output, 10 API calls, and you can sort of see all the different models and how much that would cost. So it's dollars for most of these models. So just something to think about, and it'll kind of feed into what I want to talk about next. So the inference cost is fugazi. It's hard to understand. It's often hidden. People don't really get exposed directly to it if you're not a software developer writing to these APIs and paying it directly yourself. any of the free or paid web-based chatbots like OpenAI or Claude are going to give you significantly more inference than the cost of the underlying APIs would be. So if you're paying $10 or $20 a month to OpenAI and you're using it a lot, you're probably you're using significantly more inference than $10 or $20 worth if you're paying for the API calls. And similarly, if you have a service like Copilot or Cursor, you're going to pay them $10 or $20 a month for that service, and they're doing all the inference against these backends for you. And there's no way they're covering their costs on those things if you're using these products any reasonable amount of time. If you're using it for a couple hours a day, a few days a week, you're generating way more inference API cost, even at scale, even at their discount, than the $10 or $20 is going to cover. And we've seen that. We've seen, these products slow down, they back off on the model quality, they try to charge you, they make you bring your own API token, or they try to charge you for these pro subscriptions. We've seen it from almost everybody. Devin is doing it. Copilot is starting to charge more. Cursor is really trying to get you to upgrade and pay to go faster and to use more context in these models. And there's also a lot of stunt pricing. Like right now, Gemini 2.0 is free. It's not supposed to be free, but it's free. So who knows? But the bottom line is it's an inefficient market. There's not a lot of cost transparency. It's really hard to tell if the current pricing is reasonable or which way it will go. I mean, there's a theory that everything gets cheaper over time as we scale. I don't know. I'm skeptical of that. And partially because we don't know what the right price is. The one, sort of way you can know is if you provision your own LLMs and do your own inference. Like if you do something like Amazon Bedrock and you provision an LLM, then you can sort of understand your throughput and what it costs, like what it actually costs, less their markup, sort of. But anyway, it's expensive. It may be that it should be more expensive than it is now. It's definitely more expensive than the $10 or $20 a month people are paying for these bots, for these tools. So let's talk about the Cursor context problem. And I don't want to pick on Cursor. I use Cursor every day. I think it's a great product. I think the team's doing awesome work, and they're not unique in this problem. So when it first came out, and I'm going to put some words in their mouth. I don't know that I heard anybody from Cursor ever say this, but I think the general vibe was, hey, we have these large context models and we have these tools that can take sort of bigger bites than maybe Copilot just writing one function or doing command line completion. And the idea is, hey, we can just send your whole code base over to the model, which you can, but not for $20 a month because you're going to run out of that. $20 is going to get spent very quickly. So I think when I first started using Cursor, it was great, and it sent a lot of context. You could see that it was sending a lot of files over. I have a dog in the background that's having a dream. But what I've seen lately is, with tool usage especially, Cursor and other LLMs are doing the same thing. They're taking much smaller bites. They're sending way less context. So instead of sending 5 or 6 files over, it's sending no files over, and Cursor's saying like, oh, hey, let me grep your code base and see if I can find this term. Oh, give me 10 lines of that file, and then give me 30 lines out of the middle of that file. And I mean, I've seen it do 25 turns in one question and basically cap out and fail because it had so many tiny tool calls trying to take these little tiny bytes when it could have just sent the context over and solved the problem easily. So I think what we're seeing is they're trying to optimize the amount of context by having the least context possible to solve the problem, and trying to maintain good results. And it's getting worse. It's getting slower. It's getting more expensive, and the quality is getting worse. So everything's going sort of the wrong direction. Maybe because their venture investors aren't subsidizing them forever. The sort of joke on Reddit was like, part of the reason that Cursor was successful is because they're giving you $1,000 a month of inference for $20. That's not a great business model. So anyway, I think that's a problem that we're seeing in a lot of these tools, especially tools that aimed at software development or knowledge workers are trying to solve kind of bigger problems. It's getting harder to cover that context cost. So there's some ways to beat it. You can buy local. You can run your own inference. You can run Ollama and run models on a local machine, a pretty beefy local machine. I don't know if you want to spend $30,000 on H100 to run Llama 4, but you can run DeepSeek on a MacBook, and it's not bad. You can host them. You can build your own hosting systems. You can use something like Amazon Bedrock, which has both demand-based pricing but also provisioned LLM. So if you want to go run, a Claude 3.7 on Amazon Bedrock and just pay the actual compute cost of that, you can also do that. So there are ways to control the cost a little more, so you're not just subject to this, however many cents per 1,000 tokens fee. And so a lot of those solutions also are going to help address data security and privacy and compliance concerns. I think there are increasingly arguments for use cases where people are not comfortable sending their data to OpenAI particularly, but really any of them. So sometimes you want to be able to do this all inside your own infrastructure and inside your own compliance boundary. So that's another kind of benefit to this sort of buy local or provision your own. And the other argument that I'm going to make, and I don't have data for this, but I think I have anecdotes. I've seen this, which is I favor context over the hotness of the model. And an example is Gemini Flash has a 1 million token context window, and it's 5% of the cost of Gemini 1.5 Pro. And Gemini 1.5 Pro is definitely a better model. It does slightly better on all the benchmarks. Not radically better, but it's a better model. But if you give 1.5 Flash 1 million tokens and you give Gemini 1.5 Pro 50,000 tokens, or maybe on a smaller example, let's say I go to Gemini 1.5 Pro and I say, here's 50 lines of code, and I go to 1.5 Flash and I say, here's my entire code base. I think you're going to get a better result out of Flash a lot of the time, and possibly for less cost. So I think there are ways to not do what the tools are trying to do now, which is figure out how to cheap out on the context to cut the cost, but actually find models that work better with more context that are lower cost and do that. So the bottom line is I think having tooling that lets you try all these things is part of what's important, and that's part of what this demo I'm going to show you is going to show. So I think, as I said, I think there's a lot of movement right now to control context. And I think in a lot of cases it makes sense. You want to control the cost, and you want to kind of box what these things are going to cost and to operate. And for a lot of things like AI guides and task agents, and if you need some AI agent to book a flight, like the amount of context and the number of tools and tool calls it needs to do that is pretty small. Like you're not going to need to give that a lot of context. So it's going to work just fine with a good model and a little bit of context. But I think there are some hard problems that require or would benefit from having a lot of context and being able to very explicitly control the context that you're providing to the model, so that you're not trying to sort of game it. You can really take full advantage of everything the models can do. And I'm thinking about a AI research assistant, and I don't mean like a chatbot. I mean like a legit, like we're doing cancer research kind of research assistant, or things like if you're trying to fight systems outages, which is something was a big thing I worried about a couple of jobs ago, or dealing with cyber attacks, which something I dealt with in my last job. You're trying to solve a hard problem. You're not particularly cost conscious about that point. So you want expertise, and you want high quality problem solving. So the use case I came up with was I want to build an agent for solving hard problems with access to the right tools, trained by an expert, initially me, and how to solve a specific kind of problem using those tools. So that's the sort of beginning of what we started to build. So we have this product called TeamSpark Workbench, which I'm going to demo, which is a local app. It's a desktop app, a GUI app, and a CLI for Mac, Windows, and Linux. It supports pretty much any LLM, hosted or local. It allows full transparent control over the exact context that's being sent to the LLM. It supports tool usage via any MCP tool. I think it's one of the, slicker interfaces for using tools that I've seen in a tool like this. It supports references, which are managed context or memory. So this is sort of how we can collect facts or any data really and feed them into our agent. It also supports rules, which are essentially just prompt instructions. They can be contextually included. They can be brought in by keywords or by tool usage or manually included. And what you end up with really is this agent or model that can be instructed to create and manage its references and rules. So it's learning and self-training. It can remember things, and it can train itself, and it can learn when it's solved a problem, how to solve that problem in a similar way in the future again, which is pretty interesting. So I'll talk a little bit about the organization just before I get into the demo. We're organized around workspaces, and the workspace is the combination of the model configurations that you're going to use, the system prompts, references, which I said are sort of our shared memory, rules, and tools, the tools that you're going to use. And all that configuration is stored in a directory. It's all JSON and Markdown files. It's super easy to sort of modify or tweak to your heart's desire, just using file tools or the command line if you want, if you don't want to do it through the GUI. So the combination of everything in a workspace is really, I think, an intelligent agent that's built for a specific purpose. So this may be coding, or this may be cybersecurity research, or this could be anything. And so if you want to think about it, you have access to this great model. And let's say, okay, I'm working on a Ruby on Rails project. So I want this agent to know about Ruby on Rails. So we can pull in some rules. Maybe we can pull in some references. And now we have, and this is sort of what Cursor does. There's lots of templates for this to say, okay, great. Now you know about Ruby on Rails. But let's say you have a specific version, like an older version of Ruby on Rails that you want this thing to know about. So you can go tweak it some more there. And you can actually use the product to do research and write its own references and rules as you're sort of building this expertise in. And then let's say, well, that's not enough. I want to actually know about my project. I want to know what the project does. I want it to know how it's organized and where to find things and sort of what the rules of the road are and what the functions of the product are and what the challenges are. So you can continue to build these rules and references and tools to build very specific expertise. So now it's not just like, well, I have a general bot that sort of knows how to code and it probably happens to know how to code a little Ruby on Rails. It's like, no, I have an expert in this specific Ruby on Rails project. Maybe I spent a couple hours building that and now I have this expert that can help me solve some harder problems. All right, so we're going to do a quick demo. So we'll start out, we'll just kind of walk through each of the tabs. So like I said, we're organized around workspaces, so you can open and create workspaces, switch to recent workspaces. If you have multiple windows open, you can easily locate workspaces in other windows. Pretty straightforward. We have a system prompt. So this is basically the prompt that's going to be sent with every message across every chat session. And you don't really need to put much in here. I have a little bit of system prompt around how references work, just because some of the models have struggled a little bit with that. I could have done that as a rule. I also have this thing. The user likes to be referred to by informal names like bro, dude, boss, captain, and chief. And partially I use that because this is how I know that the system prompt is being listened to when I go test it, which we'll see later. So we have references. And these can be any arbitrary collection of data. This is just a big bunch of markdown here. So we have a description, a priority level, a status. You can enable and disable these things. You can also pull them into a chat session or pull them out. And then you have whatever content you want here. So this can be anything. And they can be large if they need to be. We have rules, which work very much the same way. A rule is going to be just I'll sort of do a quick add, but it's the same thing. You're going to have a name, a description, a priority enabled, and then whatever the rule text is. So this is where you do your kind of prompt engineering. We have tools. So these are MCP tools. If you don't know already, MCP is super popular lately. It's this model context protocol that Anthropic and Cursor and a bunch of people have been big supporters of. So there's thousands of these things now that'll plug into pretty much everything and let you use tools, any kind of tools that you want. We've taken the approach to let you kind of manage the tools that are involved in a given workspace. Sending the tool descriptions over can be a lot of context, and sending too many tools, if you had 50 tools in here, we've seen the models get confused when they have like too many tools to choose from. So if you're building something that can solve a problem with 5 or 10 tools, we've sort of found it best just to have those 5 or 10 tools. So pretty straightforward. I'll give you an example of what they look like. So here's the file system tool. This is this is kind of the Hello World first tool that everybody installs, and shows, you can see they can read files and write files and edit and do things like that. We can see it's connected. We can ping it, and we can see the raw configuration. And this is the server log. So if the server outputs anything to standard error when it starts up, you'll be able to sort of see this error. And most of them do if they error out. Some of them do even if they don't. So file system has some output. So we can go in and edit those, and we have a clean little editing environment. We can add environment variables if we want. We can also switch to JSON mode. And this is nice because this is the exact same format that every other product that uses these things uses. So you can just sort of cut and paste and drop a chunk of JSON in here that expresses the tool that you want to use. And I'll come back and give a little bit of an example of that. But for now, we have the file system tool. We can test it. So let's say we're going to do list allowed directories, and that's going to send no arguments, and it's going to get these allowed directories back. So it has access to the one directory called test files. And let's say I want to do that. So I can come in here and say, show me what's in test files. So this is just sort of verifying that these tools work and are installed properly. But these are tools that the LLM is going to use later. We have a SQLite tool, which is super simple. And then we have some internal tools. So we have a tool for references this allows the LLM to create references, update, delete, sort of everything to sort of, understand how references work. So I can see I have one reference in here now called About Me. Same thing for rules. So with these internal references and rules tools, that's what allows us to have the model essentially remember things and train itself. So we have a model that sort of can evolve as we use it. So let's just jump into a chat. All right, we'll start out here. So to start out, we'll pick a model. This model we have now is called Frosty, and it's a test model that I wrote that just replies happy birthday no matter what you type in. It's not super useful. So here's what we have. We have a bunch of providers. So we have Anthropic, which we connect directly to. This is the set of models they provide. We have OpenAI. These are all the OpenAI models. So we're getting these in real time from the servers to see the actual set of models. Here's Google Gemini. Okay, we have Ollama running locally. And in the case of Ollama, what it's actually going to do is it's going to connect to which is what it's done here, is connected to my Ollama server, and it's enumerated the models that are running on that, and it's going to let me pick one of those. So I only have Llama 3.2 running, but if I had DeepSeek on here also, you'd be able to select either one of those things. And then lastly, we have Amazon Bedrock. So Amazon Bedrock is their fully managed service. I don't have any provisioned models. So these are just the models that are the pay-as-you-go models that you get when you sign up for any account. And I've also filtered them down. Actually, in all these cases, I filtered them down so that these are only models that support tool usage and that are primarily chat models. So no embeddings models and no models that don't support tools. So you have a bunch of models you can pick from. So I'm going to pick Gemini 2.0 Flash, which I feel like is my favorite model, especially because it's pretty inexpensive and it does super well. All right, so now we've picked Gemini Flash. So let's start out with something really simple. Let's say, what's my name? And he's going to say, sorry, Chief, I don't have access to that information. So he called me Chief, which means he saw the system prompt. And I can type in, I'll show this in the command line, but I'll just do this the easy way for now. So I can go to context. I have this about me reference, so I can add that. So now that's part of our, and I can ask it again. Now he knows my name because he has a reference that has a bunch of information about me that he was able to access. So let's see. What else do you know about me? And he gives me the rest of the information. So not super rocket science. So let's try something a little trickier. All right, can you put the information about the files and test files, including file name, size, and date, into a new database table? Let's see how it does with that. This is a little chattier. It doesn't always go the same way every time. All right, so I think this will have worked. So let's go back and look what we did. So it usually understands the test files as a directory that it can access, and it doesn't ask me these questions, but I don't have the model temperatures really locked down, so it can be a little bit of an adventure. But finally, I told it to look up the allowed directories, so it did that. So when I have a tool call, it looks like this. I can see a tool call, file system, list allowed directories. If I pop it open, I can see the arguments and the results and the response time. So I can see the tool calls that it's making. So he found that list of the allowed directories, found that directory, asked me if that's one I wanted to use. I said yes, and so he says okay. Looking in this directory, he's going to list the files, get the info, create a table, insert the file. So he does file system list directory, then he does get file info for each of the 3 files that it found, and then it does a SQLite create table of file info. That table already existed. Okay, I didn't clean this up before I ran the demo. Whatever, let's do that. Let's let him drop the table and create a new one. That's what he suggested. Okay, so he dropped the table and created a new table. So let's look at another thing. Let's look at statistics. So for this chat session so far, we've got 8 messages. The AI responses are 16 in total. That's 16 turns. So that means every time it responds, and sometimes when it responds, it needs to call a tool, which then I return, and then it responds again. So you sort of don't see all those back and forth. But this is the total number of turns that the AI took, the total number of responses I got. We're at 30,000 input tokens, 1,000 output tokens. And then for the last message, it took 5 turns. It did 5 tool calls, and we have 12,000. So if you want to look at the last message, you can see that it did 5 turns. And this is sort of interesting because one of the things that we'll see, particularly with the Gemini models, is it often will call tools in parallel. So often it will call something like these 3 SQL writes. That'll all be in one turn. It'll basically give you one turn that says call these 3 tools in order. In this case, it happened to do them separately, so it turned out to be 5 turns instead of a couple of turns. Anyway, let's see. Show me what database tables I have. Okay, it says only have file info. Let's say, show me its content. Okay, so it's showing me the content of file info. So it basically did a directory listing, then it got information about each of the files, put that into a database table, and now it's giving me the table contents back out there. So let's say, show me that as a table. Okay, so show me that as a table with no escaping or backticks. All right, I'm not going to fight with it here. Okay. Yeah, it's doing. I've had this problem happen before where it gets excited about showing me a table and it shows me the raw markdown, escaped markdown. Wow, it's just not going to do it. There we go. Okay. So it took a couple of times to get it to figure out how to show me a table. It usually gets it right in the first time. But again, like I said, it doesn't always work that way. So now what we're going to do is we're going to have it, see if we can get it to learn. So we're going to say, can you make a new rule so that you use markdown list when returning list items and you use tables and returning multiple items with attributes in the way you did above? Again, a lot of times it'll just do it. It won't ask you first. You could write a rule to tell it not to ask you first. Okay, so it's created a new rule. So it made a format list and tables. When presenting a list of tables, use a markdown list. Multiple set of attributes, use a markdown table. Let's say that's not good enough. Okay, so it's updated the rule. And now it has the do not escape markdown when displaying, ensure the markdown's rendered correctly. So now it has a rule that it will use in the future. It already sort of knows that in the context of the session, but it has a rule that's now learned how to output tables correctly. It's not rocket science, but it's just a demonstration of the general philosophy. And obviously, like this usually goes a little quicker than this. I'd argue with it a little more than usual. So let's do one other thing. So let's go look at how we install a new MCP server. So if you go to the main GitHub repo, it's going to give you this just thousands of these MCP servers that you can add into the LLM. And we try to make it easy to install them. So we're going to install this one called Fetch. So they all kind of look like this, and they all have some instructions that look like this. So we can literally just copy that over. We can go to tools. We can say we're going to add a server. We're going to JSON mode. We're going to paste that in. Save it. And now we have this fetch tool installed, ready to go. It's connected, ready to run. We can go test it. I'm going to have it get this David Heinemeier Hansson article that I kind of like. Just because it doesn't work on every URL, but I know it works on this one. So it's going to go run, and it took about 1.5 seconds, and it converted that whole web page into text, which is sort of cool. So now that tool's installed, I can do something like, say, so go get me the contents of this file. Okay, so we got the contents of the article. And say, see if we can add a reference for me. Okay, he actually fetched it again. Usually you wouldn't do that. Usually it'll just remember from last time. But it created a new reference called DHH Believe, which is the text of that article. So this is sort of the way, I mean, you can imagine much more complex scenarios than this, where you have much more complicated tools and you have rules in place that you've worked with the LLM to build so it understands how to use all these tools in context or in concert with each other. But yeah, the idea that I can be going out and doing research and give it a PubMed ID and have it go get me the contents of that and turn that into a reference, and I can use those references later. Lots of possibilities for sort of how you can make this thing work. But the basic bottom line is we can use tools and rules. The LLM can interact with the tools and rule system itself, or with the rules and references system itself. And in that way, I think there's a potential to build some really powerful applications, so that you can just go make a workspace, start building this tooling yourself, and building rules and references, and sort of training these agents to become, something like Cursor, but sort of for anything, but for any problem domain. I think there might be an application to cybersecurity research to sort of go get the right set of tools to do certain kinds of cybersecurity research, go pull in your ground truth and make references out of them. And you can do that through the model if you want. And then build rules to essentially sort of guide it through how to do some of this kind of problem solving and how to solve some of these cybersecurity research challenges. So anyway, I think there's lots of interesting opportunities for that. It's a pretty light demo. I wanted to show the basic functionality wired up. It was a little clunky because the model argued with me a little bit more. I will say that as these things evolve, like as these workspaces evolve and you put more rules in place, the models get sort of cleaner, the interactions get cleaner, it understands what you want it to do more, which is kind of the point of the rule system, sort of a super prompt system. But it's designed to be easy to use, but still pretty powerful. I'm going to show the CLI just briefly since it exists. Let's do help. So we have some available commands. To do the models, let's switch to Gemini again because it's my favorite. Okay, we're in the Gemini model. Let's look at the tools. So this will be just what you would have seen in the UX. It'll show, like, here's the fetch tool, SQLite, file system, references, so all the tools that we already saw. And then let's also do references. So it knows about the About Me reference. I launched this before I created the other reference, so it's still working off the configuration that I had, but it knows about the About Me reference. And I can do the same thing. I can say, what's my name? He doesn't know, and I can say @ref about me. What's my name? And now he knows my name. And if I say references, now I can see. So if you have a list of references, the star means the reference is included in the current context, and the dash means it's a reference that exists but is not in the current context. And then let's do one last thing. So we'll do stats. So we have a stats command, and we can see the same sort of thing. 2 user messages, 2 turns. I didn't have to call any. Well, I could do that. I could say what else. Let's see if he's going to argue with me as much as his buddy did. No, so he didn't have any questions about that. So you can see he did a tool call, list directory, path, test files, and he said, okay, bro, the files in the directory test files are, and these are the 3 files. So he called me bro, which means you got the system prompt. So basically the same functionality that you have in the GUI app, only you have it in the command line. And the reason for that is partially because they're a command line nerds who like command lines. But the real reason is that as a terminal app, you can run this in an IDE or in any other kind of tool that supports terminal apps. So if you want to run it in something like VS Code or Cursor or whatever, you can just run this in one of those terminal sessions. And so you can actually have an interactive session where this might be modifying code or files, and you'll be able to see those in your development environment. So I think that's kind of the use case for that. All right. So I don't have the model configuration user interface. I have it. You can type the model parameters in JSON. It's a little bit complicated because there are a lot of models. The models have different parameters. Even models from the same vendor have different ranges for the parameters and different parameters they support. It is super important, and this is what I found doing prompt engineering for TeamSpark, which is that I'll give it like a clean example. You want to nail the temperature down on some things, and you want to have it not so nailed down on others. So if you're trying to make something that's sort of chatty and seems like a person, you want to have the temperature such that it's giving a lot of variability. But if you're doing, let's say, hardcore research, you want to get the same answer every time. You want to understand you're going to have a predictable path through a set of algorithms or processes. You want the temperature locked down, so it's going to give you the exact same answer every time. And that's just one example, but I think it is important to be able to tune these parameters. So I think ideally this would have some model configuration user interface and understand, like, for each model from each vendor, which parameters they are and kind of what they do. I think a little more chat session management. So being able to, the chat sessions themselves are just a big JSON chunk, so they're pretty easy to like save to a file and load from a file. I think being able to edit it, to be able to look at the individual chat round trips and see the statistics and maybe remove things from the context or maybe back up a little bit. That's something that I've wanted to do. Sometimes you don't. Sometimes you go off the rails, and the going off the rails is part of what teaches the LLM to write a rule to make sure it doesn't go off the rails in the future. But sometimes what you want to do is you sort of take a path that isn't productive, and you just want to back up 4 or 5 steps to where things were going right, because now you know the right way to do it. So that should be pretty easy to do. And I think also a cost calculator would be kind of cool. But again, that's like a lot of metadata about the different models, and that's changing all the time. Like, you do have the token, so you can at least do something with that now. And then the last thing is the automatic reference and rule inclusion. Right now, it's manual. The idea is that it'll pull it in based on keyword context, based on tool usage. The model might be able to pull references or rules in on its own if it knows what they are. So if it thinks it needs to pull one of those references or rules in, the model might actually do it. So that's a pretty small increment, but something else that's sort of on the shorter list. Anyway, I think it's an interesting tool. The demo didn't go as smoothly as I would have liked, but hopefully you get the gist of it. I think it's it will allow people to build some pretty popular some pretty powerful solutions for solving some sort of harder problems that throw more context and give a lot more guidance in solving some sort of harder problems than maybe some of the turnkey off-the-shelf tools do. I haven't quite decided if this is a product yet or if this is just something I'm going to do open source and put out there. But if it's interesting and you want to play with it, let me know and I'll shoot you a copy and I'd be happy to get some feedback on it. Anyway, thanks.